the next section here, okay? And kind of where we're going next. And that is here, we've talked a lot about forces, okay? And again, this is not going to be on the test on Wednesday. You haven't done any homework on this yet. We're just starting it. But I want to start now because if we wait till next week, we want to get it going a little bit. All right. So we just started talking about forces and how they're expressed mathematically as vectors, okay? And we spent a lot of time on forces, and we're halfway there to the puzzle, okay? Because there's something else that we need to understand if we're going to have a complete understanding of statics, okay? We need to understand moments, okay? We need to understand moments, not just forces. We need to be able to understand moments. Ooh. Hold on, I opened this up in the wrong way. Here we go. Let me get this back. Okay, here we go. All right. We need to understand moments or torques. Okay? That's going to be able to help us have full understanding of how stuff works in statics. Okay? Because if we just analyze the forces, we don't have enough to solve much. Not only do the forces sum to zero, but the torques, or what we call the moments, also sum to zero. Okay? All right? Those torques are also important. Okay? So, what is a moment? What is a torque? Basically, it's the ability of a force to cause rotation. Okay? We haven't been looking at that much. We haven't talked about rotation yet. But we have to understand this part in order to fully understand statics. Okay? The ability of a force to cause rotation. Okay? And what are its units? Okay? The units are usually expressed in two different ways. Certainly our English system, foot-pounds. Okay? And some of you say, oh, I've heard of foot-pounds before because I've learned about tightening lug nuts and things like that. You know you have to tighten it to so many foot-pounds, okay, when you're tightening a bolt or something like that. Sometimes the directions will say, tighten this to, X foot-pounds or whatever. Now, sometimes I'll say foot-pounds, sometimes I'll say pound-feet. It does not matter, okay? Foot-pounds, pound-feet, foot-pounds, who cares, okay? And then in the SI metric system, we'll often say Newton meters, okay? But in each case, it's a force times a distance. In each case, it's a force times a distance. That's what torque, that's what moment is. Moment is not just a force, it's a force times a distance. And this is really important stuff. We've been doing a lot of stuff just with forces, and forces are the most fundamental. But you've got to understand moments too. And eventually we'll be writing equations of all the forces equal to zero and all the moments equal to zero. Okay? So we'll have more equations. All right. So let's think about this before we get into the math and the stuff like that. Let's think intuitively about this. All right? Let's say you are trying to loosen a bolt, okay? You've got a wrench. And let's say this bolt is a really tough one, okay? It's just really not moving, okay? It's not moving, okay? And you want to loosen this one up, okay? And it's just not getting there, okay? And so where are you going to grab that wrench in order to try to turn that thing as much as you can? Here or there? Yeah, the one the farthest away, right? You are going to grab here at the farthest. You're going to grab far away, right? Because you know intuitively that if you have to loosen that bolt, that you've got to grab that wrench at the end of the wrench, not toward the center where you're turning. Okay? The same thing happens with a heavy door. If you're trying to open up a heavy door, okay, you don't try to push the door near the door hinge. Okay? If away from the hinge as possible, that's going to make it a whole lot easier to push that door open. Okay? So what we learn when it comes to turning stuff, it's not just the force. It's how far it is away from where the axis of rotation is. Because in this case, this bolt here, right, this bolt has an axis of rotation probably right there. At some point there. Okay? Get that clean up. It's got some axis of rotation right there. Okay? We're rotating about that point. And so the further away you get with your force, the more torque, the more moment you're going to be able to give it. Okay? Now, why, if you have a wrench and you want to get more moment out of it, why don't they just make wrenches super long? Sometimes you don't have a lot of room. Yeah. Anybody know else why you wouldn't want to make, why they don't make, if you get more turning power with a wrench, why don't they make 4-foot long wrenches? They'd probably break, yeah. And you don't need that kind of torque, and they probably break. And if they didn't break, you know how heavy they would be? Oh my gosh. They'd have to be really heavy. And it'd have to be a big honking wrench that's super heavy in order to hold that kind of force such that you could, turn something. But yeah, you'll notice, if you need a big industrial application to turn something, the wrenches get bigger. And not just thicker, they get longer, because the longer the wrench, the more torque you're going to get. Okay? All right? So that's going to help you there. All right? So that's the key I want you to remember now. Think, okay, a force times a distance gives me the moment, and I can see that the further distance I'm away from the axis of rotation, the more moment I'm going to get. That's just intuitive if I'm tightening something or I'm loosening something. Okay? All right, so let's start diving in a little bit to the math today. We're going to ask ourselves this question here, okay? We're going to do this 2 different ways today, and then when we get back a week from today, or if you're watching this on Friday, my Friday students will be watching this, then we'll get back on Monday. Get back on Monday, the 23rd. And get into another mathematical method of doing this. But today we're going to get to the 2 most intuitive ways, okay? And then on the 23rd, we will go over and do it using cross products, okay? Now, cross products are not as intuitive, but they're nice mathematically, okay? Very good mathematical tool. All right, so let's do this intuitively. Here we go. It says determine the moment of the force about point A. Okay, using the perpendicular distance method. Okay, now, what I'm going to tell you intuitively here, and I haven't given you any stuff yet, but I'm going to tell you intuitively, before I give you equations, I want you to think about this. I want you to say, okay, the moment is equal to the force times the distance. See, okay. Force times distance. Moment is equal to force times distance. Okay, got it. Got it. Okay. All right. And here's the deal. It's not just any distance. Okay? It's not just any distance. All right? Because if it were any distance, you wouldn't know which distance to use for the because it's the distance between the force and the point that you're trying to do moments about. It's what we call the perpendicular distance. Okay? So in this case, it has to be the perpendicular distance. The perpendicular distance. Okay? And I think this will become clearer with this example. Okay? The moment, the torque, is the force times the distance. But it's not just any distance, it's the perpendicular distance. Okay? If it was any distance, if you wanted to calculate the moment in this picture here, if you just said any distance is the moment force times distance, somebody could say, okay, if the moment about A here is going to be that 30-pound force times 5 feet distance, right? Because it looks to me like the distance between that force that's applied at point B there and point A looks to me like the distance is 5 feet. So if you're going to say the moment is equal to force times distance, it sure looks to me like the force is 30 pounds, the distance is 5 feet, 5 times 30 is 150, done, game over. No, that's wrong, because it's not just any distance, it has to be the perpendicular distance. Okay, so how do you find the perpendicular distance? That's what our method 1 says. So how do we do the moment about A? Remember, the A is this point right here. Make sure we're all clear. That's that point there. Okay, that's A. So how do I get the moment about A? Well, one method is to draw out the vector, the force vector, and determine the perpendicular distance. So here's what I'd suggest you do. If you have a straight edge, this is handy. You don't have to have a straight edge because you could freehand this. Okay, you don't have to have a straight edge, but if you have a straight edge, it's nice. You can use it. What I want you to do is I want you to draw this vector here, and I want you to extend it. Okay, like that. What we're doing is you're drawing that 30-pound vector, and you're just extending the line. That's what we call the line of action of that 30-pound vector. Okay, you're just extending the line. And you'll notice, by the way, that the angle between that 30-pound vector and the horizontal is given there as 60 degrees. Right? That angle there is 60 degrees between the horizontal and that 30-pound vector. Okay? So, how do we determine the perpendicular distance? It's easy. All you have to do is draw a line between point A and this line, that's the line of action of the force, but that line has to be perpendicular. Okay? So what you do is you draw a perpendicular between A and the line of action. Let me draw it for you. It doesn't have to be perfect. Something like that. Now, how do I know that's perpendicular? Well, I just said it is, and I would write this. I would say, oh, that must be a right angle. That must be 90 degrees. Okay? See that? Okay? That's a perpendicular. The D, this blue line D is the perpendicular distance between point A and the line of action of the force. That's exactly the line we're trying to find. I need to find D. I need to find that distance. So the question is, how do I find it? Well, it's actually pretty easy. Notice here that you have a right triangle. Okay? Let me draw here another part of the right triangle. See it there? See the triangle? So what's D? What's the side D? If the bottom side is 5 feet, if this is 5 feet, what's D? Well, remember here, that's a 60-degree angle, right? This is 60, so this other side is going to be 60 as well. See that? So I think, if you'll notice the hypotenuse of that triangle is 5 feet. Therefore, D is equal to 5 feet times the sine of 60 degrees, right? 5 sine 60. Can somebody do that for me on the calculator? 4.33? Okay. So that's the actual perpendicular distance, is 5 sine 60, 4.33 feet. So now, what's the moment about point A? The moment about point A is equal to the force, which is 30 pounds, times its perpendicular distance, which is 4.33 feet. So can you take that number and multiply it by 30? 129.9. Good. 129.9 foot-pounds. Okay, we're almost done. You can write foot like this. Oops. Foot-pounds, like that. Okay, we're almost done. We don't know what the sign is. Is that a positive moment or is that a negative moment? Okay? Now, how do you know which way it's going? What you want to do is you want to ask yourself, which way is that force going around A? Let me draw it for you so you can see it. That force is going around A like this. You see it? The force is kind of turning A that direction. You see that? Because if you were to apply that force, how is it going to rotate about A? It's going to rotate like that. You see it? So is that clockwise or counterclockwise? That's the only two rotations you got. Counterclockwise. Okay, now, what we're going to do in statics is we're going to say counterclockwise is positive, and we're going to say clockwise is negative. That's our sign convention. Okay? So that's positive. Now, if you'd like, what you could also do, and I see a lot of students do this, which is a good thing, I think, is you could say, instead of just writing 129.9 foot-pounds, you could also write CCW, just to make sure we all know that's clockwise. So counterclockwise, not clockwise. Counterclockwise. Everybody see there? Okay, so that's that. Let me do one more thing, though. This is a fine and dandy method, but it's really not the method I recommend. The method I recommend for solving this is really method 2. Okay? Remember what I always say in this class? Components, components, components? A better method would be to do what I call the component method. All right. So how do we do the component method? Well, the component method, same idea here. It's moment is equal to force times distance. But here's what we're going to do. What I'm going to do here is I'm going to take that 30-pound force at 60-degree angle there, and I'm going to break it up into two components. I'm going to have a component that's pure vertical, like that, and I'm going to have a component that's pure horizontal, like that. See that? I'm going to have a vertical component and a horizontal component. Okay? Or if you label it like this, an X component and a Y component, like that. X, Y. Okay? Now this is easy. You should know how to do this, right? We've done a few of these now. Now, of course, that 60-degree angle is, maybe not the side that we're used to or whatever, but hopefully you realize that this vertical component here in red is equal to F, write this better, is equal to F times the sine of 60, right? Which is equal to 30 pounds times the sine of 60, right? What's 30 times sine of 60? Maybe somebody can help me with that one. What's that, 25.98? Okay, thank you. So that's 25.98 pounds. That's the vertical component. And then obviously the horizontal component as shown here is going to be F cosine 60. Okay, so that's going to be 30 times the cosine of 60 degrees. And I know the cosine of 60 is half, so this is going to be 15 pounds. Okay. Now here's why I like the component method so much better. When I asked you, what's the moment? What's the moment about A? Okay? All you have to do is say, well, it's the force times the perpendicular distance. In this case, the perpendicular distance between the red line, which I extend like this. See how I extended that red line? Draw a vertical line that goes right through point B. Draw a vertical line through point B. What's going to be the perpendicular distance between a vertical line through point B C. Yeah. So the moment about A is going to be equal to the force, which is the 25.98 pounds, times 5 feet. Okay, but hold on a second now. Is that, okay, now, that what direction is that going to be? If you take that red line and you put it upwards, what direction is that going around A? Well, it's the same thing as we did before, right? It looks like this. It's going to turn A that way, all right? Which is going to be counterclockwise. That's positive. Now, what about the blue line? Take a look at that blue line now. We got that done. Don't do any calculations yet. What about the blue line? Now, here's what you do. Extend the blue line. Draw a horizontal line all the way across. There's A. What's the perpendicular distance between that blue line and point A? 0. It goes straight through A. Now, another way of asking this, in case you get confused, instead of saying what's the perpendicular distance, ask yourself what's the minimum distance between the blue line and A. That will get you the same answer. Okay? So what's the minimum distance between the blue line and A? Well, the blue line goes through A, so the minimum distance is 0. Okay? So in that case, if you're going to calculate the moment about A from the blue line here, the moment about A is going to be easy. It's going to be 15 pounds times 0 feet. 0. Done. Nothing to it, right? So the answer for the moment about A down here is going to be that plus 0. And if you work it out, 25.98 pounds times 5 is 129.9. And again, counterclockwise. So you get the same answer. That's what I'm trying to say. Okay? So basically what I wanted to do today is introduce the concept of moment. Remember that it's force times distance, but it's not just any distance. It has to be the perpendicular distance. And remember, the perpendicular distance, another way of saying it, is that it's the minimum distance between the point and the force. And remember, when you have a force, you create its line of action. Draw a whole line for that force so that you can better visualize it. Okay? If you're confused, don't worry. We're going to keep practicing this when we come back in a week, and then we're going to do some more stuff as we go.